So here are the powers of 120, and these powers are basically like, I guess you could say, they're not exactly just big powers of 12, but in base 10 numerology, or base 10 mathematics, I should say, they work precisely like this. You have 120 to the first power, which is 12, with 1 0. You have 120 to the second power, which is 144, with 2 zeros. Then you have 120 to the third power, which is 1,728 with 3 zeros, which gives you a total of 1,728,000. And it just basically goes on this pattern, forever and ever. At some point, I get to the point where I no longer write the full number after the fourth power, and I just write this times 10 to the whatever, because that's essentially what it is. It's very similar to base 12, and this is just one example of what I focus on. Now, what you might be saying, why 120? Well, you see, this basically ties in not only to Eric Larson's work, who is a man who made a channel called Duodecimal Division, but it also sort of aligns with certain Babylonian principles, like the fact that the Babylonians used a base 60. And essentially the 60, the circle, their understanding of what 360 degrees could have been was a lot like, it was like a hexagon, sort of, and each side of that hexagon might have had something like 60 degrees, right? 60 degrees on each 6 sides, and that's 360. A third of that, of course, is 120. 120 is 120 degrees is like a triangle, in a sense. You got 100 degrees, 120 degrees here, 120 degrees here, and 120 degrees here, which makes a full circle. And this is a simplified version of a base 120 numeral with a 1 followed by a fancy looking symbol for a 0, representing 120 to the power of 1 times plus 120 times 0 to the power of 0, right? And 0 times 1 is 0. Another interesting thing is in Eric Larson's work is how he has connected the square root radii to the idea of why each one of our numbers 0 through 9 plus 2 extra in base 12 originally used a diagram of each one of the square root radius circles. So each one of these circles are square root radii, and I had a example of this that where Eric Larson has more examples, but this is roughly, the square root of 1, which is 1, the square root radius of 2, which is 1.414, then the square root radius of 3, approximately 4, 5, and 6, right? Now, I don't memorize, a huge amount of what he pointed out, but what we can see here in this length of 1 is that we get this thing that looks kind of like the stem of a 1. And we can just see this right here. This is the square root radius of 1, which means it has a length of 2. It has a length of 2 inches. And if we line this up with this, and we show the marks here, essentially it shows a numeral for 1. And you can go to Eric Larson's channel called Duodecimal Division. He explains this much better than I do. And another example of this I could show is if you go to the second circle, square root of 1, square root of 2, you put your trace paper over here, and you would trace the top of this to the point where it gets to, the other side of the squares that you use for the radius, and then you bring it down like this, and then you go this way a length of 2, and this gives you the numeral 42. And he goes over why each one of our numbers in our modern day Arabic numeral system looks the way it does, and he goes over all numbers 0 through 11, why it's possible that the person who originally made the 360 degrees might have even used a base 12, and how this can kind of align with things. But I do know that the Babylonians also recognized possibly the 360 degrees, and there might be some kind of link between these two systems, this concept of the Babylonians base 60 and the base 12 number system. And I'm using a base 120 because it is I'm not just using it, I'm using it as another base because it's a fractal. That means it is exactly 1 times 2 times 3 times 4 times 5. And so it has a lot of unique divisibilities that you wouldn't normally have in normal, I guess you could say, in normal numbers that you would use as a base. Another interesting thing about the number 120 is that it is a number that I guess you could say if you take 120, right, and you multiply it by 12, essentially, in a base 10 mindset, that would be the same as the 6 times 60, right, which gives you the 360 degrees in a circle. Well, if you do this same thing with base 12, you take 120 and you multiply it by its 10th, which would be 12, and you would get the number 1,440. The number 1,440 is significant because this is basically the 360 degrees times 4, and this is also the number of minutes in a day. So, that's an interesting thought, and these are square root radii. They do use 4 sections. So I'm taking these things. I'm trying to see how many connections I can find and see if I can come up with a scientific way to represent base 120 very similar to what Eric Larson is pointing out with this whole base 12 thing. And we'll see where I get from there.